Autocorrelation length is an interesting statistical or signal processing approach to look at how shapes relate to themselves as we move the surface relative to itself. Now that seems like a mouthful, so let's unpack this a little bit. If I have this surface right here and I create a copy of it, if I put the copy of the surface right here underneath it, I'll try to draw it the best that I can. This copy matches up 1-to-1. If I place the beginning of the surface here and I place the beginning of the copy right here, they match exactly. It's a 1-to-1 relationship. However, if I shift the surface over a little bit and make a new surface that is the same surface, but it's shifted a little bit. There's just a little bit of shift right here. I moved it over just a little. The surface doesn't match up 1-to-1 anymore. In fact, now it's not quite the same because of this little bit of offset at the beginning. Maybe now it's only matching 0.9% of the texture. The match isn't as good. And if I shift way over here now and make the same surface, if I make the same surface shifted farther to the right, and it's an identical surface, now it may only be matching 0.1. So the amount of match, or the amount that one surface predicts the other, decreases as I shift farther and farther away. So I have one copy of the surface being shifted and compared to the original surface. And as we do this, we can make a graph. The graph tells us how well the surface correlates with itself. It starts out at 1.0, but the more I shift, the less the surface matches itself. This is the autocorrelation function. Autocorrelation. And the autocorrelation tends to decay the more that I shift. Now we'll typically shift in millimeters, and we'll watch how much the surface decays away. In standards, we can compute this curve. We shift the surface various amounts and determine how well it's matching up with the original. A surface that's lumpy, for example, we can shift quite a bit and still match, but a surface that's kind of spiky and fuzzy, we can only shift a little ways before we fall off the peak. So this has a long correlation, where this has a very short correlation. The length to get to 0.2, the distance we shift to get to 0.2 correlation is the, let's say, roughness autocorrelation length. So RAL is the amount of shift to achieve only a 0.2% match. So the amount that we shift before the surface no longer matches itself, in fact it only matches at a level of 0.2, is the autocorrelation length parameter. We can do this for roughness, we can do this for primary, we can do this for waviness, but what this is representing is, in the case of a lumpy surface, we have a roughness, let's say, autocorrelation length that's relatively high, and a surface that's spiky or fuzzy with short features or narrow features, we'll say, not necessarily short in height, but short wavelengths, we have an autocorrelation length that's low. So the autocorrelation length tells us something about the width of the features within the texture.